Hi students, welcome to the session. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSE, AIML, MLR Institute of Technology, Hyderabad. In our previous class, we learned Dijkstra's algorithm. In this session, we are going to see how Bellman-Ford algorithm works. So, overview of the presentation. So, first we see introduction to Bellman-Ford algorithm. So, after that we discuss algorithm with one example, and finally we discuss about time and space complexity of the algorithm and advantages and disadvantages of Bellman-Ford algorithm. Outcome of this lecture: at the end of this lecture, you all are apply Bellman-Ford algorithm to find shortest path between nodes in a graph. Introduction to Bellman-Ford algorithm. The Bellman-Ford algorithm is a single source shortest path algorithm that calculates the shortest path from a source vertex to all other vertices in a weighted graph. So, unlike Dijkstra's algorithm, which requires non-negative edge weights, Bellman-Ford can handle graphs with negative edge weights and also detect negative cycles. In our previous class, we learned about Dijkstra's algorithm. What is the disadvantage of Dijkstra's algorithm? So, Dijkstra's algorithm can handle only weighted graphs. The disadvantage of Dijkstra's algorithm is it cannot handle negative edges. Okay, that is the disadvantage of Dijkstra's algorithm. So, how we overcome means by using Bellman-Ford algorithm. So, let us see the algorithm. So, Bellman-Ford algorithm. In this algorithm, we have 5 steps. First step is initialization. Second step is relaxation. Third step is detection of negative cycles. Fourth step is output, and fifth step is termination. In initialization, we set the distance to all vertices as infinity except for the source vertex, which is set to 0. So, relaxation means here, for example, if you have n vertices, then say n minus 1 times you have to perform this relaxation. Iterate through all edges in a graph for a total of n minus 1 rounds. So, what is n here? So, n is number of vertices. For each edge u comma v, what is u comma v? So, u is source, v is destination in the graph, where u is the starting vertex, source, and v is the ending vertex, that is a destination. Here we check the condition: if distance to v via u is shorter than the current distance to v, then update the distance of u comma v. So, what is the condition? Same as Dijkstra's algorithm. So, if distance of u plus cost of u comma v is less than distance of v, then distance of v equals to distance of u plus cost of u comma v. That is it. Okay. Now, we execute these instructions how many times? N minus 1 times, n minus 1 times. That is a relaxation. Iterate through all edges in the graph for a total of n minus 1 rounds, where n is the number of vertices. For each edge, so for example, there is 10 edges. For all these 10 edges, you are going to find the distance. So, next one, detection of negative cycles. So, after completing n minus 1 rounds of relaxation, so perform one more round. If any distance is updated, it indicates the presence of a negative cycle. Here, for example, we have, so let us consider A, B, C, D. Okay. So, we have 4 vertices. Let us assume these are the weights. Now, here we are going to, in relaxation phase, so we iterate 3 times. Why? There are vertices are 4. So 4 minus 1 3 times we are going to execute this phase, relaxation phase. After completion of 3 times, one more time we are going to execute same instructions. Again you are going to find the distance. But here if any distance is changed, then we assume that there is a presence of negative cycle in the graph. Okay, we discuss with one example. So here output of this Bellman-Ford algorithm is, we have two cases. So one is you are going to find the shortest distances from source to all vertices in the graph. Otherwise you are going to find, you detect negative cycle in the graph. So coming to termination, here the termination is, the algorithm terminates after completing the required number of relaxation rounds or detecting a negative cycle. That means if there are n vertices are there, so how many times you are going to iterate? N times. Okay, so n minus 1 for relaxation. So one more iteration to detect the negative cycle in the graph. So let us consider a simple graph A, B, C. These are the directions. So let us assume this is the 4, 5, minus 3. Now let us assume A is the source, A, B, C. A to A distance is 0. Initially these are infinities. Now A to B the distance is 4. 4 less than infinity, so update 4 here. Similarly for C, update 5 here. Now identify which is the smaller one, 4. So now select B and make A as a visited, and now we select B. Now if you observe for B there is no edge, so B is also visited, and finally C also visited. Now what is the distance? Here what are the distances? A to A is 0, A to B is 4, A to C is 5. But if you observe the graph here, A to C is 5, but from C to B it is minus 3. So for A to B the distance is 5 minus 3, 2 here. But actually what we got? 4. So that is a disadvantage in Dijkstra's algorithm. Okay, now so how we overcome means, so by using Bellman-Ford algorithm. Okay, another case is detection of negative cycle. So these are the edges. Let us assume A to C is one edge, C to B is another edge, B to E. Okay, now 4, 5, minus 3. Here, so how many edges? 3. So how many times we are going to apply the relaxation? So relaxation 2 times, 3 minus 1, 2, so 2 times. Distance of B from A, it is 2. Okay, in next iteration again, so 5 minus 3, 2. Now it becomes as 0. In next iteration it becomes as minus 2. Okay, now here the value of B is changed from 2 to 0, 0 to minus 1 because of this cycle. The Bellman-Ford algorithm will detect either the graph contain negative cycles or not. Okay, so let us assume, so this is the graph. So how many vertices? 1, 2, 3, 4, 5, 6. So number of vertices are 6. So how many times we are going to relax this? N minus 1 times, means 5 times. Okay, so let us execute. So first iteration, here I am writing the values A, B, C, D, E, F in first iteration. Okay, so coming to first iteration, so what is the first step? Make source as a 0, the remaining are infinity. It is similar to Dijkstra's only. Okay, so now find distance A to B. Now write all edges here, A to B, A to C, A to D, B to E, CB, CE, DC, DF and EF. So these are the edges. Now find distance. So A to B is 6. Condition is the same. If so D of U plus so cost of U comma V less than distance of V, then distance of V equals to distance of U plus cost of U comma V. Now AB means distance of A comma B. Now U is A, V is B. Okay. Now A to B. So what is A to B? 0 plus 6 less than infinity. So it is 6. Next A to C, 0 plus 4 less than infinity. So it is 4. A to D, it is 5. 5 less than infinity. So it is 5. So here we write 6, 4, 5. Okay. What is the next edge? B, E. Now U is B, V is E. Now distance of U is 6. 6 minus 1, 5. 5 is less than infinity. So here you write 5. Next C, B. Now what is the so distance of C here? Distance of C is 4. So 4 minus 2, 2. So 2 less than 6. So here you update the distance of B with 2. Next CE. So CE, distance of C is 4. 4 plus 3, 7. So 7 less than 5? No. So ignore. Next distance of D to C. So D to C, the distance of D is 5. So 5 minus 2, 3. So 3 less than 4. So 3 less than 4. So replace the distance of C with 3 now. So next D to F. So D to F. So distance of D is 5. So 5 minus 1, 4. So 4 less than infinity. So 4 here. And E to F. So distance of E is 5. Cost of E to F is 3. 5 plus 3, 8. 8 less than 4? No. So ignore. Now after first iteration, so A to A distance is 0. A to B it is 2. A to C it is 3. A to D 5. A to E 5. A to F is 4. Okay. So first iteration is over. Again same algorithm in second iteration. Now so what is the distance of A to B? A to B distance is 0 plus 6. 6 less than 2? No. So no update. Again A to C distance is 4. So 4 less than 3? No. So ignore. A to D 5. 5 less than 5? No. So ignore. Coming to next one B, E. So B to E. Here so B distance is 2. So 2 minus 1, 1. 1 less than 5? Yes, 1 less than 5. So update here 1 here now. The distance of E is 1 now. Next CB. Distance of C is 3. So 3 minus 2, minus 1. Minus 1 less than minus 1? False. So ignore. Next C to E. C distance is 3. 3 plus 3, 6. 6 less than 1? No. So ignore. Next D to C. So 5 minus 2, 3. So 3 less than 3? False. So E to F. Distance of E is 1. 1 plus 3, 4. 4 less than 4? False. So ignore. Second iteration is over. So now 0. B is 2. C is 3. D is 5. For E it is 1. F it is 4. So E is changed here. If there is no modification in the distances, then we reach the shortest distance from source to all the vertices, but here E is changed. So next another iteration, same. So A to A 0. So A to B here 6, 0 plus 6 less than 2? False. Next A to C is 3. A to C is 4. 4 less than 3? False. So A to D 0 plus 5. So 5 less than 5 false. So next C to B. If you observe C to B, the C to B is cost of C is 3, weight is minus 2. So 3 minus 2 it is 1 now. Now again B to E 1. So cost of B is 1, 1 minus 1 0. And next so D to C, so 5 minus 2 3 only. C to E 3, 3, 3 plus 3 6, 6 less than 0 false. Now so D to F, so 5 minus 1 4, so no change. E to F, the weight of E is 0, 0 plus 3 is 3 now, so 3 less than 4, so update 3 here. Okay. Now what are the values? 0, the distance of B is 1, C is 3, D is 5, E is 0, F is 3. Next fourth iteration. In fourth iteration we get the same values 0, 1, 3, 5, 0, 3. In fifth iteration also, so we will get same values on 0, 1, 3, 5, 0, 3. Now so these are the shortest path from source A to remaining vertices in the graph. 0, 1, the 0 means A to A is 0, A to B is 1, A to C is 3, A to D is 5, A to E is 0, A to F is 3. Okay. So time and space complexity. In Dijkstra's algorithm, the time complexity is big O of number of edges into log of vertices, number of vertices. Here n minus 1 times, that means V times we enter into the loop. So it is big O of E, the number of vertices are V. So time complexity of Bellman-Ford algorithm is big O of E V, where E is the number of edges and V is the number of vertices. So coming to space complexity, it is same as Dijkstra's algorithm, big O of V. Advantages and disadvantages. So advantage is it handles negative edge weights and it detects negative cycles. So disadvantage is time complexity. So why? Say n minus 1 times relaxation and another 1 time for detecting cycle. Okay. So the time complexity is high when comparing to Dijkstra's algorithm. Coming to summary of the session. In this session we will learn Bellman-Ford algorithm. So Bellman-Ford algorithm is a single source shortest path algorithm that calculates the shortest path from source vertex to all other vertices in a weighted graph. So weights may be negative weights also. So this algorithm have three parts. One is initialization. In initialization we are going to initialize source vertex distance as a 0 and the remaining vertices distance as infinity. In relaxation phase, n minus 1 times we are going to find the distances of all the edges present in a graph, and last step is detection of negative cycles. Okay. So this is about Bellman-Ford algorithm. I hope you all are understand Bellman-Ford algorithm. If you have any doubts, ask your questions in comment section. I will answer all your questions. Thank you.